Hi everyone. So the topic that we are doing today is compounds. We did atoms and elements in the previous lesson. You can access the playlist and watch the previous video. Let's get started with today's topic. Compounds. What exactly are compounds? A compound is basically a substance that consists of two or more elements, two or more than two elements that are chemically bonded together. Now, for example, let me explain this with an example. Let's say this is element X, right? This is just an element. If it's present singularly it's out there, it's just singularly present, not bonded to each other, it's considered element X. We say that this is element X. But let's say element X decides to bond with another element Y. And then element X and element Y decide to bond with element Z. Now this is going to form a compound. This would be considered a compound. Why? Because we've got three elements, element X, element Y, and element Z, that are chemically bonded together, right? Because they're like sticking right next to each other. This shows a chemical bond. Now let's say if I was to draw them separately, not really connected to each other, not really right next to each other, this is what it is going to look like. Yes, this is called a mixture because this shows that they're not chemically bonded together, that they're not right next to each other. They are physically present. We call this a physical bond. Mixtures form physical bonds. However, in compounds, we are going to see chemical bonds. And how do we spot if something's chemically bonded? There are going to, their surfaces, the diagrams are basically touching each other. Now, this definition of a compound is really important. It has shown up in your past papers for about 1 to 2 marks. If the examiner gives this definition as a 1 mark question, you're supposed to give 1 bullet point. And if it's for 2 marks, you're supposed to introduce 2 points. And you're supposed to also explain the points, right? So these are the 2 bullets the 2 very important points that the examiner is going to be looking for, that your marking scheme marks you on. No, the examiner does not really care about all of the extra stuff. All they care about is this key term, chemically bonded. If this is missing from your question, the examiner does not care about substance or that, or no. It's not an English exam. They're not looking for your English, right? You can also not just say random stuff like, oh, in a diagram, their surfaces need to be touching each other, the diagrams need to be touching each other. No. They're looking for the scientific key term, chemically bonded, and that is exactly what you're going to be graded on. And the second key point that the examiner is looking for is 2 or more elements. So these are the 2 key terms that are important that you need to give to the examiner. Let's try coming up with the chemical formula for this compound. We see that there's 1 element for element X, 1 for element Y, 1 for element Z. I can basically say that this is their chemical formula. Their chemical formula is going to look something like X, Y, and Z. Let's say in another situation, I had two atoms for element Z and 1 atom for element X. In this situation, your chemical formula would look something like Z2X. Okay? Let's do some real examples rather than taking random formulas like random variables like X, Y, and Z. So let's take carbon dioxide. Pretty sure that most of you are aware of this, you've heard of this, carbon dioxide. Now, the chemical formula for this is CO2. And you need to remember this, okay? This is the part that you are supposed to memorize, right? Now, this means that CO2, this tells me that there are two particles of the oxygen element, two atoms that are bonded to one carbon atom. Yes, because there's nothing next to C and there's two next to O, right? So this basically means that there's a one that's next to C, because we don't really like mention it. If you write this as C1O2 or CO2, it would basically mean the same thing. It does not really matter. So carbon dioxide, you're supposed to know the chemical formula for this. Let me draw a nice cute table. Okay, so we've got carbon dioxide, then we've got magnesium dioxide, magnesium iodide. Magnesium iodide is denoted with MgI2. This also means that magnesium, there's one element of magnesium and there are two for iodine. If you're ever confused, let's say they do not really write magnesium iodide and they just give you MgI2 and you're confused what Mg and I stands for, again, what is the periodic table for? You're immediately going to open up your periodic table and you're sorted. Let me plug in the periodic table so things do not really get confusing, but make sure to always open up your periodic table like in another window or have a few printouts of it right next to you whenever you're doing chemistry. Super important. You need the periodic table for almost all of the concepts. There's no concept in chemistry that the periodic table is not going to be used for. So here we go. So as you can spot iodine, this is where iodine is, yes. So iodine is denoted by an I. So this is where iodide is coming from like two elements of iodide bonded chemically to one element, one particle, one atom of magnesium. Then we've got potassium bromide. Potassium bromide. Potassium bromide, where is potassium? This is potassium bromide. This means that it is bonded to bromine. Where's bromine? This is bromine. So this potassium bonded to this bromine. They are going to together form KBr. Where did K come from? K is the chemical symbol for the element potassium. So KBr. This tells us that there was just one element of potassium and one element of bromine, one atom of bromine or one particle of bromine. Then we have carbon monoxide. Carbon monoxide, the formula is CO. This also means that there was one particle of carbon and one particle of oxygen. Then we've got sulfur trioxide. Sulfur trioxide is SO3. One element of sulfur and three elements of oxygen. They look something like this. And then we've got water. Again, super important, H2O. Two particles of, I think I should change the color. Yes. So two particles of hydrogens and one particle of oxygen. We've got two more. Ammonia and methane. Methane, CH4, and ammonia is NH3. Now, it is very important that you're going to come across another compound called ammonium. Do not confuse and mix ammonia with ammonium. right? Because ammonium is NH4. You don't need to know that at this stage, but ammonia is NH3. Don't forget that. One nitrogen bonded to 3 atoms of hydrogen, one carbon atom bonded to 4 particles of hydrogen. Now, I want you to look at this. Some similarities. Do we not spot that when it was dioxide, there were 2 oxygens? Di. When there was mono, there was just 1 oxygen. When there was trioxide, it was 3 oxygens. This is a rule of thumb that compounds that are made up of non-metals only, the second word is going to have a mono, a di, or a tri. And it shows the number of elements, number of particles of the following element present. This tells me, the di tells me that there are 2 particles of oxygen. The mono tells me that there's just 1 element of oxygen. The tri tells me that there are 3 particles of oxygen. And this mono, di, tri concept is only going to apply to the compounds made up of nonmetals. The compounds made up of nonmetals, the second word of the compound's name is going to start with a mono, follows di, follows, it's going to be mon, follows di, follows tri, follows. Mono is going to mean 1, di 2, tri 3. And this shows the number of atoms of this element for every 1 atom of the first element in the name. So for carbon dioxide, there are 2 oxygen atoms for every carbon atom, right? This is a very important key concept that I want you to make note of. Now we are moving on to the chemical formulas of ions. Just the chemical formulas. We're not going to be going into ion formation or any of that. We're sticking to the concept of chemical formulas for this video. But for basic knowledge, we need to know what an ion is. It needs to be pretty. Yes. So what exactly is an ion? An ion is a charged particle. It is non-neutral. It is a charged particle. And that basically means that it either has a positive or a negative charge. And it is basically formed when an atom loses or gains electrons. For now, just know this, right? Just know that it's a charged particle and it forms when the atoms, they lose or gain electrons, right? We're going to go into the details, into the diagrams, into the equations and all of that later on. For now, I don't want to confuse us. Again, there are some things that you need to memorize. This table is also for memorization. Your ions, your formula of the ion, and your electric charge. These you need to remember by heart. The first one is sodium. Sodium, let's spot it on the periodic table. Let me get rid of these. Where is sodium? This is sodium, yes? Sodium is denoted by Na. The chemical symbol is Na. And if I tell you that the formula of this ion is positive, and the charge is 1 positive, I'm going to get to the explanation of why this is, just a second. Then we've got magnesium. What is the chemical formula for the chemical symbol for magnesium? Mg. Yes? And if I tell you that magnesium has a charge of 2 plus, 2 positive. Let's try and make a correlation. Sodium had a charge of plus 1. Magnesium had a charge of plus 2. Do we not see that sodium is in group 1 and magnesium is in group 2? Yes. I can also say that beryllium has a charge of positive 2. Why? Because both of them are in the second group. Yes? So this is why, just surface level information, that group 1 elements, all group 1 elements have a charge of positive 1. All group 1 elements have a charge of plus 1, 1 positive charge. And all group 2 elements have a charge of positive 2. Hence, if magnesium has a charge of 2 plus, then calcium also has a charge of 2 plus. Beryllium also has a charge of 2 plus. Lithium, being in the first group, has a charge of 1 positive. Potassium also has a 1 positive charge. Yep. Moving on to the other ions that you're supposed to remember by heart. That is chlorine. But chlorine is not the ion form of it. Chlorine is the element, and the ion that chlorine forms is chloride. Yep. What is the chemical symbol for chlorine? This is Cl. Yes? What do you think would be the charge of chlorine? Any idea? Some of you might be thinking that it is positive 7. Nope, it is not positive 7. Maybe you guys were like, oh, if group 1 elements are positive 1 and group 2 are positive 2, then maybe group 7 are positive 7. Nope. Chlorine, in fact, has a charge of minus 1. And I'm going to explain this. So this means that it has a charge of 1 negative. Let me just give you another example. Then we've got oxygen. But the element, the ion, the oxygen is going to form is going to be called oxide. And oxide is going to have a charge of 2 minus. So, 2 negative charge. And you know why this happens? You know why this happens? Because all of the elements in group 7, so bromine, chlorine, fluorine, all of these are going to have a charge of minus 1. And we were just talking about oxide. Oxygen had a charge of minus 2. Sulfur is going to have a charge of minus 2 as well. Selenium is also going to have a charge of minus 2. Tellurium is also going to have a charge of minus 2. You know why that is? Because remember this ladder that we drew in the previous lesson, in the previous video? All of the elements towards the right of this are non-metals, and all of those towards the left are metals. And metals are always going to form positive charges. And non-metals are always going to form a negative charge. Non-metals always form negative charges, and metals always form positive charges, right? And if your metals are forming positive charges, that basically means that your metals are losing electrons. Because what brings negative charge to the entire system, to the entire element? What brings the negativity? What is the negative part of an atom? An electron. So how does one thing, how does an element, how does an atom become positive? it loses electrons. So it is going to lose electrons. Losing electrons. And how do non-metals become negatively charged? They gain electrons. So always know that group 0 elements are always going to have no charge. They are neutral. They cannot form ions. Why can they not form ions? Because what are ions in the first place? They're charged particles. Group 0 elements, they are not going to have any charge. Group 7 elements always have a charge of, all group 7 elements have a charge of -1. And all group 6 elements have a charge of -2. Hence, oxide ion is going to have a charge of -2, and chloride ion, being in group 7, is going to have a charge of -1. I want you to add this here as well. All group 7 elements have a charge of how much? How much? -1. Good job. Negative. Why? Because they gain electrons. Because they gain 1 electron. If it's a charge of 1 minus, 1 electron was gained. If it's a charge of 2 minus, then 2 electrons were gained. If it's a charge of 1 positive, it means that it lost 1 electron. And if it has a charge of 2 plus, that means that it lost 2 electrons. And all group 6 elements, they have a charge of -2. Why? Because they gain 2 electrons. And group 0, that is right after group 7, also known as group 8, has group 0 and group 8 elements, they don't form ions. Just know this as of yet. Perfect. Okay, so we are done with the compounds, the definition of compounds, the formulas of the compounds, and all of the stuff that you're supposed to memorize. Then we went through the basic definition of ions that is also going to show up for 1 to 2 marks. The important key terms are as highlighted: charged particle, and formed when an atom loses or gains electrons. These are the two key phrases that your examiner is going to look for, and this is the table of the 4 ions that you're supposed to memorize like by heart. You're supposed to know the name of the ions, that chlorine forms the chloride ion and has a charge of -1, and oxygen forms the oxide ion and has a charge of -2. This is the stuff that you're supposed to remember. This is some basic stuff about the charges of different sort of elements in certain groups, but if you don't really understand this, you should go watch the video on the periodic table and the groups and the elements, and it would make much more sense. So this was it for today's video. See you in the next one. Take care. Bye-bye.